Right, next thing on the algebra docket is linear simultaneous equations. Let's go. So the word simultaneous essentially means that you're solving more than one equation at once and with more than one variable at once. We're dealing with linear ones this time, so that means there'll be no squares or anything, which should be a little bit of a relief. But they do require a certain approach, or well, a couple of approaches. We're going to look at the elimination way of doing them this time round. So here's an example we've got. Put in words. You could buy 4 teas and 1 cake for £3.30 or 2 teas and 1 cake for £2. So what's the price of each of those individual items? Now, if we wanted to treat this as a simultaneous equation, the first thing we would do is we'd try and write it in terms of letters. So we would change this to 4t plus c equals, let's keep it in pence, 330, and we could say 2t plus c equals 200. And the problem with this is obviously that there are two letters in the question. There's T and there's C. There's the price of a cup of tea and there's the price of a slice of cake. So we need to get rid of one of those. We need to simplify the issue. And the way we're going to do it is we're going to subtract the second equation from the first equation. So because of the way collecting terms work, that means we're going to subtract the 2t from the 4t, and that will leave us with 2t. We're going to subtract c from c, which will leave you with nothing. And we're going to do 330 take away 200, which gives you 130. In other words, and you could tell this, I guess, from the context, 2 cups of tea cost £1.30. Now, what would we do with that? Well, we want to find the price of 1 cup of tea. So we'll divide that by 2. And we'll get that a single cup of tea is 65 pence. Now, we still need to work out what the price of the actual cake is. How could we do that? Well, what we could do is we could take that information that tea costs 65p and we could plug it back into one of the original statements. So we knew that 2 teas plus 1 cake is equal to £2. So we could say, well, okay, 1 cup of tea is 65 pence. So 2 teas would be 2 lots of 65 pence, would be £1.30. So we could say 2 times 65 plus c is 200. 130 plus c is 200, and then we could subtract that 130 away and get that a cake is 70. So we could get that a slice of cake, in this case, is 70p. These are very good deals, by the way. So the general idea with what we're looking at here, solving simultaneous equations by elimination, is that you take the equations you're given and you manipulate them. You add or subtract them together. We're going to multiply and divide them a little bit later, with the aim that we want to get rid of something. We want to eliminate the variable, hence the name. So in this example, what we did by our subtraction was we eliminated cakes from our equation and simplified it down to just something involving tea. Okay, we're not going to come back for context for a while now, but I want you to remember this as the example of where it starts. So sometimes we add and sometimes we subtract, and the question is why and when do we do that? So we've got 4 different examples here, which we're going to run through. This may take a little bit of time, but it's a good example of where these come in. So what about the first question? Remember, we're trying to eliminate a variable. Would we add or subtract these two things together? Well, let's think about adding first. If we were to add, and let's just try this with all of these, maybe add always works. What would we get? Well, we get 8y from the 5y plus 3y. And then what would we get from the g's? Well, we have 2g plus minus 2g, which will give you 0. That would eliminate the value of g. We'd also have 18 plus 14 is 32. So adding is the right thing to do there. What about on the second question? We'd end up with 10x plus 10x is 20x. We'd end up with minus 3b plus 7b. So that's minus 3 plus 7 is 4. So plus 4b is equal to 260. And that doesn't work there. That doesn't work because nothing's been eliminated. We've still got x, we've still got b in the question. You can tell you've made the wrong decision if that happens. What about for the next one? So that was 3x. So 7x plus 3x, that's 10x. 5f plus 5f is 10f, and these add up to 26.5. Again, that's wrong, because we haven't eliminated any variables there. We've still got x, we've still got f. And what about the very last one? Well, we're doing x plus minus x, which is going to go away to 0, and minus 4 plus 2p, so that's going to be overall minus 2p. And then 10 plus minus 4 is 6. So in two cases there, adding worked out great. In two cases it didn't. Let's just try some subtractions on the ones that it didn't work out. They should hopefully work, but we need to make sure they do. So we're going to minus this time. 10x, take away 10x, yeah, that gives us 0. And then we want to do minus 3 minus 7 is going to give us minus 10b here. And 30 minus 230 is going to give us minus 200. For the third one, if we change this into a minus, we're doing 7x, take away 3x, that's 4x. 5f, take away 5f is nothing. And then 16.5 minus 10.5 gives you 6. So there are some situations where adding is the correct thing to do, and some where subtracting is the right thing to do. And it kind of all depends on the signs. So in this question, we were eliminating the g's, and they had different signs. In this question, we were eliminating the x's, and they had the same sign. What I mean by that is they were both 10x. They weren't 10x and minus 10x. In this third question, we were eliminating the 5f's, and they have the same signs. Plus 5f, plus 5f. And in this last one, we were eliminating the x's. Let's just draw that box a bit neater. And they had different signs. We had x and we had minus x. So if you want to remember this as a sort of shortcut, then this is what we use. That if the things we're eliminating have the same sign in the question, we can subtract to get rid of them, SSS. Whereas if they have different signs, we can add to get rid of them. Now I do want to finish these questions off to get to an actual answer here, but that's the main thing we want to take here. If we've got same signs on what we're eliminating, we subtract to get rid of them. Different signs we want to add, and then we don't have to think quite so much about what's going on. But let's finish these off. So what was our next step once we get to this stage? It's always going to be a division. So in this case, we need to divide by 8. We're going to get that y is 4. In the next one, we're going to divide by minus 10. And that's going to give us that b is 20. Yeah, it's going to change the sign. In this one, we want to divide by 4, because that's going to give us x is 1.5. And in the last one, we want to divide by minus 2. And that's going to give us that p equals minus 3. So the point of the division step there is to get, obviously, if we have a number of this variable, to get us just down to one of those variables. It's what you do if you were given the question, 8y is 32, what is y? And then our last step, once we've done our division, and remember we did this with the cups of tea, is to substitute that value into one of the original statements to work out what the other one is. Now it doesn't actually matter which one you pick. I always like to pick the one that looks easiest to work with, which is the one with the most pluses normally, but it's up to you. So I'm going to use, let's use a different color there, that won't show. I'm going to use this equation here, and I'm going to sub into it that y equals 4. So we'll have 5 times 4 instead of 5y plus 2g equals 18. And that'll give us 20 plus 2g equals 18. And then this is just an equation, and you've solved equations like this many times. Take away the 20 to get to 2g is minus 2, and then divide by 2 to get us that g equals minus 1. So our answers there are y equals 4 and g equals minus 1. Now y and that g look very similar. There we go. What about for the next one? Well, we've got b as 20. Which one looks easier to you? To me, this one looks easier to deal with, so I'm going to use it, but it's up to you. Now, don't make the mistake of doing 10 times 20 here. We found the value of b, and b is the second variable in our equation. So we're going to have 10x still, we don't know what x is, plus 7 times 20 is equal to 230. So 10x plus 140 is 230. Take away the 140, we'll get 10x is 90. Divide by 10, we'll get x is 9. So our answers there are b equals 20 and x equals 9. What about for the next one? They both look equally easy to me, so I'll choose the one with the smallest numbers. This is going to give us 3 times 1.5 plus 5f equals 10.5. That's 4.5 plus 5f equals 10.5. Subtract that 4.5, so we'll end up with 5f is 6, and then divide by 5, and we'll end up with f is 1.2. You probably want to be using calculator at that stage, but you know, up to you. It's not impossible. You can have decimals. Decimals is a thing that can happen. That's absolutely fine. And then we've got different signs here. So p was minus 3. Neither of these look perfect to me, but I'm going to use the top one, I think. But it should work with either of them, so feel free to try a different one and see how it goes. So this one says x minus 4p. So we're doing minus 4 times minus 3 there equals 10. So x plus 12 minus times a minus equals 10. Take away the 12 and we'll end up with x is minus 2. So yeah, that's 4 different simultaneous equations there. You can see in terms of what we're doing is we're deciding whether to add or subtract, then we're dividing to get the value of one of the variables, and then we're substituting that in to one of our equations to find out the other variable. There's a few more things we can say, but I've been on this particular slide for 8 minutes now, so I'm going to move on. So let's talk about a few of the things that can make your question more awkward than that. And the first thing is that your equations might not be in a suitable form. If you remember the previous slide, we always had letters above themselves. So we had A's above A's and B's above B's, and your question might not be set out that way. So we can see in the first question we've got G above H and we've got H above G, but we can easily get around that by just rearranging the equation. So I'm going to rewrite this. First equation is going to stay exactly the same. The second equation, we're going to just reorder this. So we've got a minus 3g and a plus 7h. There's no reason at all we can't write that in the opposite order with the minus 3g at the front. Just make sure the sign that's before the letter moves with it. And now we've got something which is familiar. Second question, a little bit more awkward because we can't just reorder things because they're on the wrong sides of equal signs. If you want to move things across equal signs, you do need to actually add or subtract. So what we're going to do is we're going to take away 3r on this first one, and that's going to give us 5t minus 3r equals 44. And we're going to take away 5t on this second one, and that's going to give us 2r minus 5t is minus 46. And then we might look at that and think, well, I can still make that a bit simpler as well. And I might want to rearrange maybe this one, or actually let's do the top this time. I might want to swap the order here. So I'll move my minus 3r to the front and my 5t to the back. So let's do that. We'll have minus 3r plus 5t is 44. So I think it'd be a good idea for you to attempt these questions now, but I'm going to crack on with them. If you want to pause first, it'd be an excellent idea. Remember, we're trying to eliminate, so we want to identify the things that are the same. We've got 3 G's on both of these questions here, and we've got 5 T's on both of these questions here. If it helps, put a little plus in front of things that don't have signs on it, because we're going to have to decide whether to add or subtract. In both these cases, we've got plus 3G and minus 3G. We've got plus 5T and minus 5T. These are different signs, so we are going to add. So we'll do that. 3G plus minus 3G should cancel out. If it doesn't, there's a mistake there. Minus 4H plus 7H, that's going to go to 3H. And 13 plus minus 7 is 6. So we can divide by 3 and we can get H is equal to 2. For the second one, we're going to add them again. we're going to end up with minus r from minus 3 plus 2. And we're going to end up with 44 plus minus 46 is going to give you minus 2. That's quite an easy one to fix. If you've got minus and minus, you can just change the signs on both sides and end up with r equals 2. And then what was the next step after that? Well, the next step was to take your answer and to substitute it into one of the other equations. So which one would you pick? I'm going to pick this one, but it should work with any of them. According to that, 3g, and we don't know g, minus 4h, and we do know h, we know h is equal to 2, is equal to 13. So what could we do with that? Well, we would multiply out, and then we'd add the 8 to the other side, and we'd divide by 3. So we've got our two answers here, h is 2 and g is 7. And for the second question, I might choose this as being the equation I go into, but again, any of them work. Feel free to try a different one if you want. And that will tell us 5t is equal to 3, and we know r is equal to 2, and we're multiplying because they're next to each other, and things next to each other in algebra are multiplied, plus 44. So we'll end up with 5t is 6 plus 44, which is 50. And then we can just divide by 5, can't we? So we can get t is equal to 10. So it's just a case of substituting, and then a little bit of, I want to say, fairly simple rearranging at the end to get our final answers. So the second one gives us r is 2 and t is 10. Now, what about if you weren't sure if you were right? Well, we can always check. You can always check equations. People tend not to do it. But you can always check by substituting them back into the original equation. Now, if we look at what we had here, we had 3g minus 4h is equal to 13, and we had 7h minus 3g is equal to minus 7. But what about if instead of saying g and h, we use the values that we found? If they work, then we must be right. And they have to work for both of them. Now, we said g was 7, so these should become times 7s. And we said that h was 2. So these should become times 2s. Now what sums does that give us? 3 times 7, 21, minus 8 is 13. That works. 14 minus 21 is minus 7. That works. So you can always check that your answers are right. If they weren't, then that would give us an incorrect answer somewhere along the lines. But you do have to check with both equations. And we can do the same thing here if we wanted to check. We've got 5t is 3r plus 44, and we've got 2r, let's give it a bit of room, 2r is 5t minus 46, and then let's substitute in the values we know. So we know t is 10, or we hope t is 10, so 5 times 10, and that'll become 5 times 10 as well, and we know r is 2, and does that work? Well, that would give us 50 is 6 plus 44, which is true, and 4 is 50 minus 46, which is true as well. So yeah, I worked through it there, and we got the right answers. So, what about if we can't just add or subtract? So why can I not add or subtract here? Well, if I add, I end up with 8x and 10y, which is no good, nothing's eliminated there. And if I subtract, then I end up with minus 2x and 6y, and nothing's been eliminated there. What's the problem? Well, none of these letters actually match up. I don't have 3x and 3x. I don't have 8y and 8y. So what we do, and this is the last bit of the simultaneous puzzle, is we can multiply these equations to make them match. So the easiest way to make this happen is to make the y's match up by multiplying this bottom one by 4. Okay? Because that will give us 8y on the base, and we already have 8y on the top. It's not the only way we could have approached this. We could have multiplied, say, them by 5 and 3 individually and got them both up to 15x, or multiplied the top one by 10 and the bottom one by 40 to make them both 80y. But you want to pick a simple way of doing it, and the simple way is to make this both 8y. So let's do that. The top equation is going to stay exactly the same. 3x plus 8y equals 2. Let's put a little bit of a dividing line in there. The bottom equation is going to be times by 4. So we'll end up with 20x plus 8y is equal to, and don't forget to multiply all of it, minus 32. So we've now got a situation where we can do what we did before. It's just taken that extra step of multiplying up. So we've got the same signs this time, so we're going to subtract. So let's do that. That will give us minus 17x is equal to, be careful here, I was about to think I've made a mistake, but 2 take away minus 32 is what we need to do here. That'll go into 2 plus 32, so that'll go to 34. And that means we will actually have quite a nice sum. So we're going to need to divide by minus 17, and that'll give you x is minus 2. And then last step, obviously we need to pick an equation to sub it into. Let's choose this first one. I know I always seem to go to the first one. Honestly, you can pick anyone. And the first one says 3x, so 3 times minus 2 plus 8y is equal to 2. So minus 6 plus 8y equals 2. Add the 6 across, 8y equals 8. Divide, y equals 1. So our final answer, our x is minus 2 and y is 1. Could check what we did that on the previous page. Have a go if you fancy it. What about this second one? Well, this one you do have to multiply both of them. And the reason we have to multiply both of them is there's, well, okay, apart without using decimals, there's no nice way to make 5 into 7 or 3 into 5. So I'm going to make the b's the same, I think, this time. It's generally nicer to make the second variables the same. It makes the signs work out a bit nicer, but it's very much personal preference. I'm going to times this one by 5, and I'm going to times this one by 7. Why? Because then 7 will become minus 35, and 5 will become 35. Tends to be the thing that you can multiply them by each other's number. Just like when you want to find a common denominator for a fraction, you multiply them by each other's denominator. So bear that in mind. So timesing this up, we'll get 15a minus 35b is equal to, be careful here, minus 175. You need to multiply everything by 5. And then multiply the other one by 7. So we'll end up with 35a plus 35b is equal to 525. That's some larger numbers here. Probably should be using a calculator, but oh well. Identify the things that are the same. We've got minus 35b and plus 35b. We have different signs, so we're going to add together. So let's do that. 50a equals 350. Divide by 50, a equals 7. Choose an equation to sub it into. I'm going to choose the bottom one because I feel like I've only ever chosen the top. Bottom one gives us 5a, so that's 5 times 7, plus 5b is equal to 75. So this will give us 35 plus 5b is 75. Take away the 35, divide by 5. So we've got a is 7 and we've got b is 8. And all this leads us towards is this final way to say this is the method for linear simultaneous equations. First off, we multiply to make one variable the same. Then we add or subtract using SSS or DSA. Then we solve an equation to get one variable. Then we substitute to get the other variables. And that's simultaneous equations. I've got 2 last slides to go here that will delve into some of the intricacies, but if you can do this, it's 90% of what you'll get given. So this is very much 2 questions that I'd like you to try out yourself first. I will have a go, but I'm probably not going to explain them in as much detail as I did on the previous slides. So when you're ready, off you go. And I'm going to unpause in 3, 2. So for the first one, I times by 5 and 3 to make the e's the same. This meant we had to add them together, and we can divide down to get that d is equal to 6. And then I went back to my old ways, substituted it into the top equation to get that e was minus 4. You could have done it a different way, but you should have got those same 2 answers. As for the second one, I decided to multiply by 3 and 8 to make the b's the same this time. This led us into a subtract where you've got to really think about the signs. You're doing minus 15 minus minus 16, so that'll go up to 1c, or just c is minus 0.6. Then I actually realised I made a little bit of a mistake. It's actually minus 0.8, apologies. And substituting that in gives b equals 1.5. How did you do? Okay, one last thing to tie this all together. So remember how we started here. We started with a worded problem that we changed to equations, and then we looked at how we could deal with those equations. But people tend to forget that origin story. They get quite good at solving algebraically the simultaneous equations, but get confused when something's given to them in equation form. I'd like you to read these two things on the screen, have a pause, and think, what would the actual equations look like here? I will reveal the answers in 3, 2, 1. So here's what we should have. And I think the first one's fairly self-explanatory. It's just reading off the numbers there, putting them in order. For the second one, you've got to understand, obviously, that sum means add and difference means subtract. And then the fact that Edna is older means that we have E minus D as 14 and not D minus E. Once you've done that, it's just a case of applying what we've already done. So I'll finish them off, but you should be doing that yourself at this stage. So for the first one, you'll end up with A is 9 and C is 3. Just remember, if it's asked a question like this, you need to put this back in context. So we'd have to say at the end that an adult ticket is £9 and a child ticket is £3. So yeah, if context is in the question, context needs to be in your answer as well. Remember, you can obviously also check that. 5 adults plus 2 childs, that's 45 plus 6, yeah, that is 51. As for the second one, it is a case that you can just add the two things together straight away, or you could actually do it as a subtraction as well and end up with 2d is 70, 2d is 50 even. But yeah, again, remember context. This tells us that Edna is 39 and that Dave is 25. It is also possible to do that question by trial and error, but more interested in the method than the answer today. So yeah, that's linear simultaneous equations by elimination. We still have to look at substitution, we still have to look at quadratics. Simultaneous equations are a super big part of maths, particularly going beyond GCSE, but this is the intro. Enjoy.